Our channel here is going to be a hopefully a test and repair video on a Gallagher S17 solar unit, 6-volt solar unit. It's a really good unit. They've been around, or they were around for a long time. They started making this model under a green case called an S15 back in the late 90s, like 97, 98, somewhere in that range. I think like 99, 2000. They switched over to the black case version, and then I think like 2015, 14, 16, somewhere in that range, they came out with the S22, which was a glorified S17 basically, and a lot of the same parts on the inside. Just boards were different, but everything else was the same. But we're going to go through this unit so we can get it going for the guy. Now, they don't make this unit anymore. It's been discontinued. It was replaced by the basically S20 that's out now. It took its place. They had a S16 in there for a little while. That unit's been discontinued. So they got the S20 now. I mean, but those things are $265 as of late 2023 prices. I'm sure they're higher now if they're even still around. You know, depending on when you're watching this unit, they're around now. But anyways, you can see a bunch of bugs and stuff that are stuck in there between the clear lens and the panel itself. So we'll have to take the solar panel out and clean those all out of there and stuff. The rubber switch cover is missing, probably dry rotted off. But this thing is a 2005 model, so it's got some age on it, almost 20 years old now. 18-year-old unit, so I can get this thing to focus. See the G344404. That's the product code, part number for the whole entire unit as a whole. And the number below it, this one starts with 05. The first two digits is the year it was built. So this is built in 2005. The 30 is the week of that year, so 30th week of 05. If you look at the circuit board on the side there, module is what Gallagher called it, there would be a sticker on the transformer as well. Let me turn the light off, there's a bad glare. There's a sticker on there as well, and it has got, I can't see, 0530 as well. So it matches, or it's, you know, close. It's never going to be the same because the boards are built first, and then they'll assemble the units, and the serial number of that thing is what goes on this. So the boards are always built first, and then of course they build the units. So serial numbers never match identical, but sometimes you'll see like there's 52 weeks in a year. So if you say you saw a board that said 1152 or 53 or 553 49, some, you know, 2011 49th week of 2011, but then you see the unit says 1206, so it'll be 6 weeks of 2012. So the unit board was built in late 11 and the unit was built in early 2012. That's just an example. The boards always come first. Okay, well, anyways, let's put some power to this thing. Now, if you're wanting to, the customer just sent just the top cover to the unit, which is fine. The first thing I always do, if it's here or if I'm troubleshooting over the phone with a customer, is when you flip it on, does it come on at all? Does the light flash? Does it make any noise? Clicking? What's it do? If it doesn't come on at all, you know, no light at all, or it flashes once and then stops and doesn't flash again for quite a while, the first thing you want to do is check your battery. So you want to get a voltmeter, put on DC voltage. This is a Fluke 115, but you know, any digital multimeter can usually test DC volts. But you want to put on like a 10 volt setting, something you can at least test 6 volts, and you're test across there. And if the battery reads over 6, it should run. It should turn on, because all the battery does for a unit is allow the unit to turn on. It doesn't have anything to do with how much power it's putting out. You know, so if the unit does flash the light like every second or two like normal, the battery's fine. You know, the battery's all it does is make the unit pulse. That's all it does. You know, allows it to turn on. But if it's really close to 6 or less than 6, like say 5.7, that's not good. That won't run the unit. It might make it flash once and stop, but it won't allow the unit to run like it's supposed to. So let's apply power. And if your battery is under 6, you put out inside the sun with it turned off for a few days, you've either got a bad battery, a bad cell in the battery, or you've got a weak solar panel, which can happen as they age. But let's put power to it. We're going to hook on this, and the battery leads with the thing, which is nice. We're about 6.5 volts on the power supply. We're going to put power to it. Now, the unit is flashing every second or so, but it's not clicking. So, I mean, it's not discharging. So, in order for it to be a chance of having power on the output, the unit has to click. And that clicking comes from that transformer right there. On any unit that have low impedance, fence starter, or even an old solid state unit from 30 plus years ago, when the unit ticks, the ticking sound itself comes from that transformer on any model. People think, oh, it's the capacitor discharging. Well, the capacitor is discharging, but it's shoving that power through the transformer. When that power goes from the input side of the transformer to the output, when it goes through that transformer, that's the ticking sound. That's it firing through it. So the ticking noise comes from the transformer itself. So people sometimes get hung up on that, don't understand, but that's what it is, or they didn't know. So we've got a board issue to start with. So what we're going to do is we're going to unplug the wires off both the board and the solar panel. They plug up here, and the solar panel plugs up a little black connector up there, right there, and it does fit one way. Make sure when you unplug it, grab right up close. Don't grab back here somewhere, because you can accidentally pull these wires out of that connector, and then you're in a whole heap of trouble after that. All right, and there's 3 screws. There's Phillips screws. There's one there, and one hiding right down inside there. All 3 the same. So I can see some bug residue on this unit, the board. So I know that because that rubber switch covers all is missing. Now to get this board out of here, you got to grab a hold of the right hand side with your right hand, and I grab the side of the transformer over here with my left hand. You want to pull it towards you to kind of separate from the case, and then you kind of lift it up and out. That switch, oh yeah, look at that. That board is completely covered in whatever it is. So see if we can, not even coming off there. See if we can spray some stuff on here. That's a contact cleaner. And let's see if we can loosen things up. Now see if we can take a can of air and blow it off there. Getting better. All right, the rest of it's stuck on there. So I'm going to take a screwdriver and just going to scrape off, hopefully, the remaining bug guts and grime. Alright, I think this is good enough for now. Alright, put this out of the way for a minute. Alright, so it's not firing. It's cycling, but it's not actually discharging and clicking and firing and stuff like that. I've had a lot of people that call me with one of these type of things. Oh, I think my capacitor's bad. I said, why? Well, it's not clicking. It's pulsing but not putting out. I said, is it making a clicking noise? No, but cycling, yeah. I said, well, the capacitor's probably not your issue. Because personally, these ones, the capacitors don't get bad all that often anyways. So what we're going to do is we're going to check the primary side of the transformer first, which is on this side. That's the input side coming in the transformer. What we want to do is see if the winding on the primary side is open or closed, basically. And so we got fence and ground over here. That's the secondary side. So I'm going to follow these contacts here. It looks like this one goes to there. That one goes to there. So these two. So this one and I'm going to say this one. Yeah, that's a primary. So it should be a closed loop. Should be 0.1 to 0.9 on average. So we're getting 0.4. So the primary of the transformer is fine. So it should click. So there might be an issue with something over on this side with all these little doodads and gizmos and stuff, all this residue of bug guts everywhere. Or it could be a problem with, one of these parts here. Let's check the secondary side of the transformer, which basically what we can do is just ohm across the fence and ground. I don't know what it's supposed to read, but we'll check. It should read something. See, it's not reading anything at all. So first thing I think we ought to do on this particular one is change out this transformer. Let's another thing we got to do is we got to get these little plastic clip things. Little spacer, to get those out. Later boards versions that came out, I think 2008, 9, they had a different transformer on them. They were similar but different. This is the orange one. Later ones were red, and then they went to a kind of a grayish, whitish colored transformer later on. The last version they did was a whitish gray. So we're going to heat solder up, suck the solder off with this desolder braid. That's pretty standard soldering setup, nothing fancy. So let's pop this off there. So we'll desolder there. We'll push these two little tabs in. And then it pops right off. I don't see any cracks in the epoxy on burn holes. Sometimes you'll see that. There is a little crack right there, but that might just be a crack in the, might just be something in the epoxy itself. Hard to say. Doesn't stink. Doesn't smell burnt or nothing. I don't see any residue on the board. Sometimes you just see a spot in the board where it's been arcing, puts like a little white burnt residue on the board. Let me go see what I got for transformers for this, and I'll be right back. Alright, I got a factory transformer in stock. There's the new orange one, just like it. Now, what I like to do with these orange ones is I like to snip off these little, not the clip part itself, but these little nubs right there. I like to snip them off. It makes installing them a lot easier. Another thing I like to do to put these transformers in there, because it does only fit on there one way. If you look at the little holes in the board, they're not a perfect square. See, these two up here are wider than down there, so you can't get in backwards. So it only goes in one way. So to make this transformer go in there, this is my trick of the trade of what I've done for years, is I make sure that these 4 pins are straight. not tilted side to side. I'll make sure that they're straight. And then I'll grab them and I'll bend them inwards just a little bit. Just bend them in towards the center a little bit so they're kind of at an angle like that. For whatever reason, make them straight. The pins don't line up 100%. But if you bend them in just a little bit, it guides them in a little easier. So then you kind of line them up like that. Keep a little pressure. You squeeze. Kind of hold it there. And then what I do is I take a flat screwdriver and I push it on the sides. That to help push these little clips inward so they fall into the board. Something over here. Squeeze all the way in. And then you go back and you look and make sure that all 4 of them pins came through there. And then also I'll go over here on the back side, push those out to make sure that they're all the way out and clip it into that board. I don't know if this is going to solve our issue, but it's worth a shot because you can get a new board for these, but they're $100 and some odd for a new board. So this is definitely a cheaper option than buying a new board. Alright, let's flip this board like that. So that part's done. And if this doesn't fix it, I'll this corner for a new board, and I'll take this transformer off. I'll put it back to stock. And this transformer, I'm probably going to throw it away either way, good or not, just because it's 18 years old. And you just never know how long things are going to last when they get to be that age. Okay, right now the switch is up when the board's out on the table. Up is off, down is on. Because when you put the board back into the case, it's inverted. The switch is inverted, so up is on, down is off on the outside. But right now, the way it's sitting, it's opposite. Alright, and we'll flip the switch down, which is on. Didn't solve our issue because it's not clicking. So we've got some other issue somewhere else. I think our transformer was bad because it did indeed test open. So another thing it could be, there's 2 little protecting diodes right here, surface mounted ones. They're right here on the board. This one and this one. Those can burn open. You know, they look fine, they can be open. And that will, they do that to kind of help protect the transformer and the board and everything. So they could be bad. And so what we can do is test across them with a meter on diode setting. That one's shorted. That one's shorted as well. So that's probably our issue. Now the bad thing is the diodes aren't marked. Because there is a kind of a polarity or a way that diodes need to be put in. If you put them backwards, they don't work right. It don't work the circuit right. So let me see if I get another board, even a bad board that maybe I can read those and see which way they go in. Because there's not the stripe that's usually on there is all wore off. So I need to know which side the stripe's on. So let me go look at another board if I got one. Okay, I found this board here, which is a later version board. And it's a lot cleaner as well. You can see that. It's a lot cleaner. No bug residue. If this board was good, which it's not, it's been modified for something else. But let's see if we can test the diode on there. Those 2 diodes. See if we can figure out which way they go in. See, okay, that side means it's open. So which is one way. So we reverse the leads. It should be a little beep. Show me which. Oh shit! So this board those diodes may be bad on this board. Let's test down here on this one. Oop. Okay, see that diode is good. Okay. Okay, so we need to mark the board. We'll put a little dot on this one so I know which side it was. So that side is where the stripe goes. I'm going to put a dot right there. This one does not read anything at all one way. Oh, no, they read that down. Now that one's reading. So maybe it had a contact one. So it looks like the stripe is going to be on our left-hand side. Thank you, old bad board. So that's good. So let's get a couple small diodes. I don't have any surface mount ones, and so what we'll do is we'll take some of these old style through-hole type, and we can solder them in place. We'll just have to cut the leads real short, and we'll solder across those two joints right there. But what we're going to do is we need to grab a pair of needles, pliers. We're going to heat up the diodes. Oops. I'm going to zoom in for this one. This one might be kind of fun to watch me struggle a little bit. Alright, we're going to grab this diode right there. They're soldered on the left and right hand side. We're going to heat it up. Let's grab a small pair of needle or flat screwdriver. Let's get underneath it. So I'm going to just push it off there. Or lift it up, one of the two. May have to. That stinks. There's like bug gut residue on there. It's getting hot for me with the soldering iron. And it doesn't smell too good. Alright, we're just going to suck the solder off one side. And then the other. Ow. Same thing over here. As well as over here. Well, that one popped up for me. See that one right there. Popped up off one side of the board. Let's heat it up over there and pop it all the way off. Okay, now we can see if we can get this one to pop off too. Come on. Okay, there's still some solder on it. It's hanging it up. Let's see. Pull more off. Okay, let's see if we can touch right there. Okay, that one's up now. I should hopefully be able to just heat up this side there and push it right off. Oh, there it goes. Okay, so now that's taken care of. Let's get the soldering iron out, or solder, and we're going to put some fresh solder on here. Right there. Right there. There. And there. And then we'll grab those two small diodes. And I'm going to, don't need them to be very long. We're going to put them, probably cut them right there. Right there. And I'm just going to turn them up like this. Something to hold it there for me for a second. We're going to add solder to the tops, or to the end of the leads on this diode. We're going to just heat it up and add a little solder to the ends. Okay. Now these do have to go on a certain way. Yeah, it's pretty hot. Okay, there's a stripe on here. Stripes on our left, which is where we want it. We're going to put that right there. Phew, it stinks. Yeah, wire's a little long. Let's bend it in. Right around top. And we should be able to just heat the two up together. Well, it needs to be pressed down a little bit. Push down on it, get right on top of that joint. Hold the two together with solder iron on top of both of them. It should fuse together. There's that one. Now we'll do the same thing with the second one. We'll cut them back like this. Now I don't know if this is going to fix it either, but if not, I guess it's fun practice. So add some solder to this one. Add some solder here. Then we'll grab cut off a little bit of this. It's a little long. Take the solder iron. Basically, the piece I cut off was with the area that had the solder on it, so we'll just hold it right there, heat that lead up, and use that to touch against the solder iron, or the solder itself, and let it kind of get a little bit on there. Okay, so now we need to grab this, and we'll put it, how hot is this to the touch? Okay, not too, it's a little warm, but not too hot, because that solder iron gets pretty dang hot. Let's see, put it, which way do we want to put it? I'm going to put it this way, or this way. I'm going to put it this way. Side by side, right there. There's that one. And we'll take the screwdriver, push down on it. It's right over the solder joint. Push down to hold it against it. Heating them both up. Let them cool off and harden up. There. Just like that. I do want to, let's see, there's this one. I do just want to make sure that they don't touch anything they don't need to be touching. So I did bend it up. I mean, this, I think these two, can't tell. We'll grab that out of the board real quick. So make sure it doesn't touch anything it shouldn't touch. So the side of this one right here does not touch that, which is the same point as that one right there. So they do not electrically touch. So that this side of the diode is that. Oh, it doesn't touch either. So yeah, we don't want those to touch at all to that contact there. It goes around it. It goes over there. Okay, I think we've got it figured out enough to where we could hopefully, if everything goes smooth and this solves our issue. We'll apply power. Flip the switch on and it'll go to working. But we'll see here in just a second. Alright, let's back off the deal here. Flip the switch on. Hey, doesn't that's clicking? Wasn't clicking before, remember that? Let's put a screwdriver across just to kind of see if it doesn't spark. If it does, we know it's probably working, but we'll put a tester on this to make sure. Oh yeah. So a combination of bad transformer and those two little diodes right there were bad. Those were burned open, which wasn't, or burned shorted, and was not allowing the thing to discharge. So now this capacitor's probably got a charge built up in it, so we're going to discharge across the capacitor. So now that's discharged. It was not doing that before. Let's put our meter on here and see what we get. We're going to go across fence and ground, which is down here, and we're going to see what kind of power we get out of it. Voltage wise, it should be about 8 to 9,000 volts usually, typically. 9.2, 8.6, 9.6, 8.9. So we're right in that 9,000 plus or minus voltage range, which is right where it should be. Now 500 ohm load, just from experience, should be right around 2,000 plus or minus volts. Yep, 2.1. Right where it should be. So now we will probably let this thing run for a while. Just make sure we don't have any other issues with this board in here, because it did have dried dead bugs in the thing. So luckily I've got a power supply that's constant, like set to like 6.6 volts, and it won't fluctuate at all. It'll stay there and just run. Okay, so next thing that we need to do is we need to test this solar panel out. I imagine it's probably fine. You know, it's got all those bug guts in there. So let's take the solar panel out first. So we need to, there's 4 screws. Phillips screws holding this in. 1 in each corner. Don't like the sound of that. Okay, yeah, see all the crud on there. That could just all be cosmetic, though. Gallagher solar panels on some of their units were really well made. Let's take a can of air. And we'll clean off this thing. Wish I had some spray cleaner handy. I don't have any right this moment. Alright, we can do, there's 2 ways of testing the solar panel. Easiest way to test it is while it's hooked up to the board. And which I guess we could do. We can plug this solar panel into the board, which it does plug in one way. And then we'll take our battery wire. We'll plug it on to the board. And then we'll, with the unit turned off, which it is, put our meter on DC volts again. And this one I think we can leave in the room here and test it, because sometimes you have to take things outside and get actual good sunlight on there. But I think this type of panel, usually we're good to go in here. Uh-oh. We're not getting anything. Uh-oh. So the board's... So now we got to figure out, is our issue in the solar panel or the board? Because this board has a regulator system in it that keeps the protects the battery. Basically, it brings the volts down from say 10, 12 volts down to 7 volts roughly. So now what we can do is verify if it's a board or the solar panels. We could test the solar panel. You can go across the back side here. Real hard to do sometimes. Go across these little pins that are metal things holding the wires in place. Just go right across those, the red and the black where those little metal things are. And these panels usually put out about 10 volts, usually. Let's see, I'm getting jack squat out of the thing. So we've got a bad solar panel. Now, good news, bad news. Good news is I might have a solar panel still in stock. Bad news is Gallagher no longer sells one brand new anymore. They've discontinued them. And I found that out. I bought the last like 5 or 6 of them that they had in stock. So I might have 1 or 2 or 3 still floating around here. So let me go look. If I do, we'll plug that into the board and then we'll do our recheck. So, but let me go look and see if I've got one. If I don't, this might be the end of this video where I wish we could find a panel. This is glass and it's double-sided foam taped to this plastic frame here. And when we get panels from wherever, you know, as long as the dimensions were right, the plug on the end would be wrong, but we can take this wiring and solder it, wire it onto a new panel. That way the panel can be plugged back into the board. So let me go look and see if I got a solar panel for this one. Let's hope that we do. Whew. And 1 left out of those 5 or 6 I bought here a few months back. I got 1 left, brand new solar panel. Now, Gallagher themselves didn't make the panel itself. That was probably made by somebody. Manufactures solar panels. But of course I do make the plastic frame. That was their design to fit the thing. But let's plug in. We'll test the panel on its own. Verify it's good, which should be brand new. But at least we can work our way backwards to see if the test that we're doing is the right test. So all this monkeying around we've been doing, if the board ends up being bad still, where the panel can't flow power through the board to the output to the battery, then we're basically up the creek without a paddle. It can be fixed. The only way to fix it would be to put a new board and a new panel on the thing. All right, see, we're getting 7.5 volts there, but if I move this panel closer to the light or took it outside where I get good direct sunlight, then we'd get 10 some volts out of the thing. So we know the panel is fine now. Let's take this solar panel. Let's plug it in to the board. It's turned off. Let's take this battery wire, plug it onto the battery, or plug it on the board. It's turned off. Let's take this battery or solar multimeter, put it on DC volts again. Typically, you get about 7 volts right here, right around 7 volts. So we're going to go plus the minus across the battery leads. We're at 7.1. So the board's working fine. So it's letting the solar panel feed power through the board. So I got to call the guy the quote. We've got to quote him for a new panel and the repaired board, a new black rubber switch cover, because his is completely gone and might have probably dry rotted and fell off. It's probably been gone for a while because there's a lot of bugs that had gotten in there. So it could have happened 5 years ago. And over the last 5 years, bugs have made their home in the thing. That's why it is as bad as it is, as bad as it was. But we do want to run this board for a while. That thing kind of heat soak. I think warm up and run for a while, especially with all dead bug guts that were on the thing. There's still some on there. We should probably do a little more cleaning on the thing. So, but as of right now, everything's working fine. The board is functionally good, doing its job. Solar panel will be brand new. I mean, a brand new unit's $265 for a replacement unit. Repairing the board's not going to be all that much of an expensive parts. Transformer. Yeah, we got, what, 40 some minutes in this thing. I don't charge by the hour, by the minute, or whatever. I just charge by the job. You know, so, you know, we'll do a little labor for going through it, and then, you know, getting it going. And of course, the panel's not cheap. It's not a, you know, it's Gallagher branded solar panels, or anything with their name on it's always 4 times the price it should be. But anyways, hopefully you like this video. We're about 80% done with the thing. We got to get the customer's approval still, but I'll probably call them tomorrow and let this thing run all the rest of today, overnight, come back out tomorrow morning. Thing's still running. We'll probably call it a win. But here's our information. If you got electric fence box, like to send it to us for repair, we'd be happy to take a look at it. We do give free quotes and 18-month warranties on the repairs that we do. And work on all brands, all ages of electric fence boxes. We'd appreciate you if you'd like to subscribe to the channel as well. Hit the thumbs up button at least. And until next time, see you guys later on.